you know that you need to read orion.sales to create work.comp. Now let's work on adding the new variables. The Human Resources Department has indicated that the bonus for all employees this year is $500, so bonus is a constant. You've already learned to use assignment statements to update existing variables or create new variables. So you can use an assignment statement to assign the value 500 to bonus. For more information, click Review. Next, you work on defining compensation. To calculate compensation, you must combine salary and bonus amounts. For this, you can use the sum function, which returns the sum of the arguments. Here's the syntax for the sum function. You specify the keyword sum, followed by the arguments separated by commas and within parentheses. The arguments can be numeric constants, numeric variables, or arithmetic expressions, but the arguments must be numeric values. If an argument equals a missing value, the result of the sum function is the sum of the non-missing values. Compensation is the sum of salary and bonus. Both salary and bonus are numeric values. Remember to separate the arguments by using a comma. Here's a question. If salary has a missing value, what do you think the value of compensation will be? If salary has a missing value, the result is $500. In this case, using the sum function is better than using an assignment statement that simply adds salary and bonus. If one of these variables contains a missing value, a simple assignment statement returns a missing result. But the sum function ignores missing values, so compensation will always contain a non-missing value. To review information about SAS functions, click Review. The last variable to create is bonus month. Bonuses are paid the month in which the employee was hired, so bonus month is the hire month. To create this variable, you use another type of function, a date function. You might remember that in SAS, the date 0 is January 1st, 1960. From that date, all SAS dates in the future are positive numbers, and all SAS dates in the past are negative numbers. To calculate days, months, and years, you can specify a SAS date as a date value in a date function. You can use different types of SAS date functions to create variable values. For example, these date functions extract date information from the date value that SAS stores. The year function extracts the year from a SAS date and returns a 4-digit value for year. The quarter function extracts the quarter from a SAS date and returns a number from 1 to 4. The month function extracts the month from a SAS date and returns a number from 1 to 12. The day function extracts the day of the month from a SAS date and returns a number from 1 to 31. The weekday function extracts the day of the week from a SAS date and returns a number from 1 to 7, where 1 represents Sunday and so on. These date functions create a SAS date value. The today function returns the current date as a SAS date value. The MDY function returns a SAS date value from numeric month, day, and year values. Now, let's think about creating the bonus month variable again. The hire date for each employee is stored in the hire date variable. At Orion Star, annual bonuses are awarded to employees in the month they were hired. For example, an employee that was hired in April receives an annual bonus in April. So you need to extract the month the employee was hired from the hire date. You can do this by using the month function. The syntax for the month function is shown here. The function name month is followed by one argument in parentheses. The argument for month must be a numeric value representing a SAS date value. Here, the month function extracts the month from hire date. The value of bonus month is the month the employee was hired.
Let's see a demonstration of how to create the 3 variables you need in SAS. We'll begin with the Orion.sales dataset. We use a data statement to specify work.comp as the SAS dataset to be created, and a set statement to specify Orion.sales as the dataset to read. Given that the bonus amount is $500 for every employee, bonus is equal to 500. We use a simple assignment statement to create bonus. Next, let's use the sum function in an assignment statement to create compensation. Remember that the total compensation amount is the combination of the employee's salary and bonus. So compensation is equal to the sum of salary and bonus. Finally, we use the month function to create bonus month by extracting the month from hire date. We end the step with a run statement. To see the output and confirm that the variables were created correctly in work.comp, we add a proc print step. Now let's run the program and see whether the variables were created correctly. By checking the log, we can see that 165 observations and 12 variables were output to work.comp. Remember that Orion.sales had 9 variables, so we know that our 3 new variables were added. By viewing the output, we can see the 3 new variables, bonus, compensation, and bonus month. Notice that the value for bonus month is a number.
Suppose you continue working on the assignment from the Human Resources Department to provide information about each employee's compensation. You've already created bonus, compensation, and bonus month. Orion.sales contains variables that you don't need in work.comp. Of the 9 variables currently in work.comp, you want to keep only the 3 new variables you defined. In a previous lesson, you learned to exclude variables from a dataset by using a drop or keep statement. To review the drop and keep statements, click Review. Now, answer a question. Let's see how SAS processes this drop statement. SAS creates the PDV and adds employee ID, first name, last name, gender, salary, and job title, among other variables, to the PDV. Then, SAS adds the new variables bonus, compensation, and bonus month to the PDV. In the compilation phase, SAS flags the variables to be dropped from the output. In this case, the variables gender, salary, job title, country, birth date, and hire date are marked to be dropped at output time. The descriptor portion of the newly created work.comp dataset includes only employee ID, first name, last name, bonus, compensation, and bonus month. At execution, SAS reads the data from the first observation in Orion.sales into the PDV and creates any new variables. Finally, SAS writes the data from the PDV into the new work.comp dataset. SAS doesn't write the variables in the drop statement to work.comp. This process repeats until SAS reaches the end of file for the input dataset. Now, answer a question.
Now let's see how to subset variables by using the drop statement. We want to create a dataset that includes new variables that are calculated from the variables in the original dataset, but we want to keep only some of the original variables. We want to drop gender, salary, job title, country, birth date, and hire date. In the previous demonstration, we left off with this program in the editor window. We used the program to create the new variables, so now we just need to drop the variables we don't want. We add a drop statement to omit gender, salary, job title, country, birth date, and hire date. It doesn't matter whether we put the drop statement before or after the assignment statements. Let's run the program and check the log to see if the variables were created correctly. We can see that 165 observations were read and 6 variables were output. Remember that the original dataset, Orion.sales, has 9 variables. Given that we created 3 variables and only 6 were output, we know that 6 variables were dropped. By viewing the output, we can see the 3 variables that we created: bonus, compensation, and bonus month. Also, we can see that gender, salary, job title, country, birth date, and hire date were omitted from the output.
Now, try practicing in your SAS software. Now the Human Resources Department at Orion Star needs to determine how much of a bonus to provide to employees and when. The Human Resources Department indicated that the bonus amount for employees in the United States was $500, and the amount for employees in Australia was $300. But it's a bit more complex than that. Employees in the U.S. receive the bonus once a year, whereas employees in Australia receive the bonus twice a year. For this task, you begin with Orion.Sales, which provides the employee name and location information. You create two new variables, bonus and freak, based on the employee's location. Then you write the data to the temporary dataset work.bonus. By the way, the variable name freak is the frequency that the employee receives the bonus and isn't related to the freak procedure. Let's think about what you need SAS to do. You want to create two variables based on one condition. In a previous lesson, you learned how to create one variable based on one condition by using the if-then statement. Remember that in the if-then statement, SAS evaluates the if expression, and if the condition is true, SAS performs the action. For an if-then statement, SAS has to evaluate every possible condition. Also recall that to process our data efficiently, we can use an if-then-else statement. Adding the else enables SAS to evaluate the conditions only until it encounters the first true statement. Then SAS performs the action. In this case, you want to create two variables based on the one condition of the employee's location. You want SAS to determine whether the employee is from the United States or Australia. Then, based on that condition, you want SAS to create bonus and freak and assign them values. For more information, click To execute multiple statements, you need to use a do statement within an if-then-else statement. This set of statements function like the if-then-else statement, but enables SAS to perform multiple actions based on one condition. The do statement, together with the other SAS statements it contains, is known as a do group. The syntax for the do statement in an if-then statement is shown here. It's very similar to the if-then-else statement that you already know. At the end of the if-then statement, you specify the do statement, then the statements to execute if the condition is true. Notice that each do group must end with an end statement. Here, the else statement contains a second do group. Take a moment to answer a question.
Now, let's start writing the code to create multiple variables conditionally. We know that we need to read Orion.Sales, create work.bonus, and create the new variables based on one condition, the location. We'll begin with the condition that we expect to be true for the most observations. From the data in Orion.Sales, we know that the value for the United States is US, so we specify this value in the condition. Remember that this is a character value, so we put it in quotation marks. If you weren't sure that your data contained only uppercase values, you could use the upcase function to make sure that mixed case and lowercase values were tested in the condition. Next, let's write the code for the do group for US employees. We want to assign U.S. employees the bonus amount 500 and the bonus frequency once a year. Remember that each do statement must have a matching end statement. Next, let's add the conditional logic for the Australian employees. To make this program efficient, let's add an else statement with a second do group. we assign the Australian employees the bonus amount 300 and the bonus frequency twice a year. Again, we don't forget the end statement. Finally, we add a proc print step to display only first name, last name, country, bonus, and freak. Okay, let's submit the program and view the output. We see our new variables. It appears that the values for bonus and freak are based on the value for country, so the data looks good. But wait, there does seem to be a problem with some values for freak. For the value twice a year, the final R seems to be cut off. Let's see why this value is truncated.
To determine why a value might get truncated, let's consider how SAS assigns lengths to variables by default. SAS begins by creating the PDV from the variables in Orion.sales. Remember that SAS lists the variable name and type, numeric or character, and then allocates space for the variable values. Next, SAS works on creating the new variables. SAS adds bonus, which is a numeric variable, to the PDV and allocates 8 bytes for it. SAS adds the variable freak to the PDV. From the string of characters that are assigned, SAS deduces that freak is a character variable. Because SAS wasn't given any instruction about the variable, SAS assumes that the length is the amount of space the first time SAS is given a value. Once a year equals 11 characters, so SAS assigns 11 characters to the variable. Look at the number of characters for the next string assigned to the variable freak. Twice a year requires 12 characters. Now you know why the last character is getting left off in the output. SAS only allowed for 11 characters. Here's a question. How would you modify your code to allow the full 12 characters? You can change your code in several ways to deal with the situation. You can specify the condition for Australian employees first so that SAS creates 12 bytes for the character freak, or you can pad the characters for the variable in the first occurrence, or you can use the length statement. The length statement is a straightforward approach to declaring the byte size of a variable up front. SAS assigns variable lengths based on the first occurrence of the variable in the data step. So it's important to put the length statement early enough in the program to make sure that's where SAS first encounters the variable freak. To review the length statement, click Review. Take a moment to answer a question.
In this demonstration, we'll set the length of the variable and we'll remove the condition from the else statement. Here's the program from the previous demonstration. Let's add a length statement to the program and see if it corrects the truncated value for freak. Remember that it's important to put the length statement before any other reference to the variable. So we add the length statement before the if-then-else statements and their do groups. Let's submit the program and view the output. Now the full value twice a year is displayed for the variable freak. We resolve the program by using the length statement. If you were sure of the values for country, you could specify the else statement without the condition. An else statement without a condition allows anything not equal to the previous conditions to be true. Let's give it a try. In the editor window, we change the else statement by removing the condition. Next, we submit the program and view the output. We notice that the values for bonus and freak are correctly assigned based on the value for country, and the full value twice a year is displayed for freak.
Now, try practicing in your SAS. Orion Star Management has decided to pay all employees a $500 bonus once a year on their hire and anniversary date. Now, suppose the Human Resources Department at Orion Star needs a report that lists only the employees from Australia who have a bonus to be paid in December. For this task, you begin with Orion.Sales, which provides the employee name and location. Then, you create the variable bonus month by using the month function. For observations where country is Australia and bonus month is December, month 12, you create the variables bonus and compensation, and then write the observation to the work.December dataset so that you can create the report.